The recent end of Expedition 47 marked the conclusion of the on orbit portion of some International Space Station experiments that we've been talking about a lot, including cognition and microbiome, as well as ocular health. The experiment looking into the reasons why some crew members suffer diminished vision after a long duration stay on orbit. Recently, my colleague Pat Ryan spoke with the lead increment scientist for Expeditions 47 and 48, Yuri Gernhardt Ramirez, and about some of the new experiments getting started on this expedition, and about what happens next for research that is wrapped up on orbit.
We have a huge milestone in completion of these investigations that started many expeditions ago and require a lot of these subjects to complete. Now that our final set of subjects is home, these investigations will undergo what we call post-flight BDC, base data collection. Essentially, they'll go through similar type of in-flight measurements like they did during in-flight, and they will collect the data to figure out essentially what happens after they come home. And some of these collections take, it could be 3 months, it could be 6 months, and in the case of ocular health, for example, it can take close to a year to continue to take these different measurements of the eye and the vision, including tests that were not part of the in-flight portion, like MRIs and other ways to assess the health of the eye. So after all the scientists gather all that data, they'll have lots and lots and lots of mounds of data to go through and try to figure out what the big picture is telling us across all the different subjects through the years on all these various health issues that we're trying to understand better for spaceflight.
Had they gotten a start on that? Had they been reviewing the on-orbit data from the prior subjects already, and they're not saving it all up for one time?
Well, they can start assessing some of it. They can understand whether or not we think we have viable data. Some of these investigations require body samples, and some of those came home with SpaceX 8. We had a huge set of samples that came home for human research with that mission return. Others have taken place after SpaceX 8 for these specific crew members, for example, with microbiome, and those will have to wait until those samples come home to finally be able to put all the puzzle pieces together of all the data and continue to assess the post-flight data collections, if you would.
Expedition 47 meant the end of some experiments. Expedition 48 has got its own experiments that are occupying the crew on orbit. Tell me what you think are some of the highlight experiments that we'll be seeing happen over the next 3 months or so.
Certainly, there's a lot of investigations that continue. One of those, actually an interesting pair, is CSA, the Canadian Space Agency, has marrow. And that's an investigation that's looking to understand how the bone marrow transitions from its natural state into more adipose or fat tissue, if you would, in the bone marrow itself, this adipose tissue. And so that is part of the natural bone process as we age, for that bone marrow to transition. However, they are looking at how the microgravity environment accelerates that. And that is analogous to patients that are in bed rest and have to undergo long periods without activity. And so they're trying to understand how that lack of microgravity loading on the body of the bone and marrow affects not just as we understand our muscular skeletal system, but deep inside into the bone marrow, and those processes that could also affect the white cells and red cells count for possible mitigations in the future.
Are there some experiments on Expedition 48 that are not human life sciences research, some other kinds of science?
Oh yes, we have all sorts of investigations. One that we have continued, and we've seen a lot of that during increment 47, and we may not continue through until increment 49. Perhaps it's ESA's electromagnetic levitator. That is looking at a completely different process for solidification of samples. You have different samples of different metal alloys, iron, copper, nickel, and different alloys that they're looking at how they solidify. And this particular apparatus that's out there allows us to process these batches of samples and watch through the high-speed cameras and thermometers, essentially trying to assess the temperature, quick heating, cooling, and watching how that sample solidifies and the surface tension that occurs within that sample, and it's levitating. Obviously, we have the microgravity, but the electromagnetic forces help to keep it in place.
In one place.
And being able to watch how those processes happen can help us potentially yield whole new revolutionary ways of manufacturing here on Earth.
In a matter of a few more weeks, there's another SpaceX Dragon cargo ship that's coming to the station, and it's delivering some brand new science that new to the station. Tell me about some of the things that you'll find in there.
We have a couple of very exciting investigations. Again, SpaceX has come in with so many investigations to add to our portfolio. It's very exciting to have them arrive. In a few of those include JAXA's mouse epigenetics. And this is a very interesting investigation where we understand how DNA and works, right? We have this DNA sequence that tells us, okay, you're going to be roughly this height and this build and some of those pieces of who we are. But we are learning more and more with the epigenetics side of the house that there's this external to the genetics factors like diet, stress, and other different environmental conditions that actually affect how the gene expresses itself. So these functions that are happening outside of the genome itself are not changing your DNA sequence, that is what it is, but the fact that you may or may not be more susceptible to some diseases, or you may or may not be more prone to certain things happening, is heavily influenced by this environment. And we're learning a lot about that. And using our mice as a human model, one of our model organisms that we can study and translate that data, can help us understand what is going to happen for the mice that will be exposed for microgravity during this period. And they'll come home, and then they'll be able to assess their epigenetic changes in the various organs they have, as well as their offspring. Another one that's very, very, very interesting is heart cells, and that's a NASA research investigation coming up. And there's a very fascinating couple aspects to this investigation. The first is that the scientists have successfully taken skin cells and I would say deprogrammed them and turned those human skin cells into stem cells. Now, most people may be familiar with the fact that stem cells are those cells in the body when we're born that can turn into any kind of cell in the body, right?
Right.
So they've taken the skin cells and deprogrammed them, and then once they are turned into the stem cell, then they can go ahead and differentiate them or reprogram them into heart cells. And those heart cells, living heart cells, will be launching on SpaceX 9, coming to the space station to undergo some exposure, and we'll have to study them as they express themselves in the microgravity environment. And the hope is that eventually we might be able to better understand the cardiac impacts, not only to our crew members as a result of the whole spaceflight environment, but ideally we might be able to eventually lead to revolutionary ways of heart disease treatments here on Earth, and that's very, very hopeful.
Very interesting few examples of what's going to be going on in terms of science on board the station in the next few months, and we'll get you to come back and tell us about how the operations have gone.
Absolutely,
Okay.
yes. Thank you.
Yuri Guinart Ramirez is the Expedition 48 lead increment scientist.